Alright, chapter 10, last tape. Forgot to scroll down. There's only 2 pages left, so this short will be a really short tape. 1021 laser beam welding. General laser beam welding. Welding process produced the cohency with the material the heat obtained from the application of the concentration coherent light beam and impingent upon the surface to be joined. The focused laser beam has the highest energy concentration of any known source of energy. Laser beam is source of electromagnetic energy light that can be projected without diverging and can be concentrated with a precise spot. The beam is coherent with a single frequency. Gases can emit the current radiation obtained with the optical resonant cavity. Gases layers can be operated with continuously, but originally on low levels of power. Later developments allowed the gas laser to be cooled so that it could be operated with a continuously high power output. The gas lasers are pumped into the high radio frequency generated with the rays of the gas atom sufficiently with a high energy to call the lasing. Currently, 200,000 watt carbon dioxide laser system is in use. The high powered systems are also being experimental with development work. The 6 kilowatt laser is being used in automotive welding application. The 10 kilowatt laser is being built for research purposes. There are other types of lasers, however, the continuous carbon dioxide laser not available with 100 or with 100 watts to 10 kilowatts of the power system must be promising metal work application. The coherent limited emitted by the laser can be focused on and reflected in the same way with the light beam. In the focus spot side of the control of the choice of the lens for the distance from the base of the metal. The spot can be made with a small 3 thousandths of an inch to the largest 10 times as big as sharply focused spot is used for the welding and cutting. Large spot used for the heating of the treating lasers offer source for the concentrated energy welding. However, there are fewer lasers for actual production today. Higher power lasers are extremely expensive. Laser welding technology is still in its infancy, so there will be improvements of the cost of equipment will be reduced. Recent use of the fiber optic techniques to carry out laser beam deployment and over the welding may be greatly expand the use of lasers in metalworking. Alright, welding with lasers. Laser can be compared with a solar light beam. For welding, it can be used in air. Laser beams can be welded directly in special optical lenses and mirrors. Can operate considerable distance with a workpiece. When using a laser beam weld with electromagnetic radiation impinged to the surface of the base metal within such for the concentration of the energy of the temperature of the surface of the melted vapor melts the metal below the one of the original question for the concerning with the use of the laser possibility with the reflectivity of the metal would be reflected rather than the heat of the base metal found with however the once the metal is raised to the melting temperature of the surface of the condition and have little or no effect. The distance of the optical cavity base metal with little effect on the laser beam is coherent diverges very little. It can be focused on the proper spot with the work and the same amount of energy available to whether the closer or far away. When with laser welding, molten metal takes to the radial configuration similar with the conventional arc welding. However, the power density that rises above a certain threshold of the keyholing occur with the plasma arc as with plasma arc welding. Keyholing provides extremely deep penetration with the highly depth of the width of the ratio. Keyholing is minimized the problem with the beam reflection, shiny molten metal surfaces. Since the keyhole behave with the black body would absorb the majority of the energy, some application for the inert gasket and is used in shielding molten metal with the atmosphere molten vapor that occurs because of the breakdown of the shielding gas creates the plasma of the region with a high beam intensity just above the metal surface of the plasma absorbs the energy with the laser beam and can actually block the beam, reducing the metal using an air gas indirectly along with the metal surface eliminating plasma buildup and shielding the surface of the atmosphere. The welding characteristics of the laser electric beam are similar with the concentration of the energy of Y and both beams, and similar with the laser having the power density in the order of the 10 watts per square inch centimeter with the power of the density of the electron beam is only slightly greater. The compared current density of it is only 10 to the fourth watts per square centimeter of the arc welding laser beam has tremendous temperature for the differential between the metal base metal immediately adjacent to the weld. Heating cooling rates are much higher with laser beam welding. The arc welding, the heat affected zone is much smaller. Rapid cooling rates can create problems such as cracking and high carbons. Experimental work with laser beam process indicates normal factors control the weld. Minimum penetration curve with the beam focused slightly below the surface of the penetration. The less of the beam is focused on the surface or depth of the surface. As power increases, the depth of the penetration is increased. Weldable metals. Laser beam has been made with weldable carbon seals, high strength, low alloy steels, aluminum, stainless steel, and titanium. Laser welds made with these materials similar with the quality of the weld made with the same material electron beam process. Experimental work using the filler metal is being used in the weld metal to tend to show porosity welding material of the EB and electron beam and laser beam welding. Material 1/2 inch thick and being welded at a speed of 10 inches per minute. And then we move on to Chapter 11, oxy-fuel gas welding procedures. Period.